Namaste and welcome to the course of Design of Machine Elements 1. In this session, attempt is made to know how to design a rivet. So before letting you to know how to design a rivet, I kindly refer you to go through my video where all I shown over there how to consider this N1 and N2 that reflects a single shear and double shear. So where the video name states somewhere the failure in the rivets. So let's try to design the rivet. Hope so. Ready with the paper and pen. So initial, the procedure somewhere follow in this way. So you know that if I say a lap joint with rivets across and a chain arrangement, some dimensions need to be known over here. One is in thickness, as if you can see over here, H and T reflexing. And where this is a margin, where M is equal to 1.5D. If you could remember my previous video where I shown that in order to avoid the tearing of plates, this plays a vital role. M is equal to 1.5D, where M stands for margin. And a pitch, a distance between two rivets, as you could see over here. This is a pitch, a distance from this center of this pitch to the center of this pitch. In some cases, even this H has been somewhere set as a T. Kindly don't get confused between H and a T. In some cases, we do even consider H as a T. Both the same. So you could see over here another example where you could see a butt joint with the two rivets with one cover plate over in the top, and the main plate thickness as a T and the cover plate thickness as a T1, right? T and T1, and again a margin 1.5D. Again you say a pitch over here. So in one more case where I could use both two cover plates as in a butt joint. You could see here the two cover plate of the butt joint and arrangement is zigzag. So you can see the thickness of the main cover plate is in a T, and the thickness of a top plate and a bottom plate would be T1 and T2. If they are different, or even if they are same, then T1 is equal to T1, or even T2 is equal to T2, whatever the consider. One thing is very important here. This thickness of this plate come in existence while you are about to consider what's the length of an rivet. So there where these things comes in existence. Okay. Now to follow out, my first step to design would be what would be the diameter of an rivet. So for which I will be referring a data handbook, which is what I referred over here is in a 3rd edition design data handbook written by Madhavan and Balavi Reddy. So here the diameter of the pitch, the equation that I use would be this, which is of equation 5.22C of page number 64, where it says this. Here again the T would be the thickness of a main plate. Okay, thickness of a main plate or a shell. That would be in mm. So once I find the diameter here, I'm going to standardize the diameter again by going through a data handbook, which is a set of instructions given in the book. So which is in a table, you can see over here, this is a standardization diameter one. So in this video I have ample of values. So whatever I decide from this equation, I'm going to standardize the value from here. So henceforth, once if I standardize the diameter of that one, then I'll find out the whole diameter, which would be the diameter of a rivet, the standardized one what I choose from a data handbook, plus 1 mm as an all lines. So hereafter, whatever the diameter that I concern for further design, that would be the whole diameter. Can you do take care? Whatever the diameter that I use or concern for a further designing, that would be the whole diameter, which is a diameter of a rivet. Diameter of rivet here is a standardized diameter of rivet from a data handbook plus 1 mm. So further, followed by the step 2, where now we'll find the pitch of a rivet, like what should be the pitch, right? The equation will be here from a data handbook again. It would be from equation 5.23a of page number 65, right? So here you can see this, the D, I'll be substituting the values over here and I'll find out what is pitch. And another again, here one more pitch we do have, which is according to the standardization of the IBR. Then the equation would be somewhere reflects to be 5.23b of 65. In both the values, I'll substitute and find out a p. But while substituting in this, I am very much important to concern to what is this k1. K1 is in a constant, right? Refer from a table 5.a of page number 68. As you could see over here, this is a table which I referred. You can see that there are number of rivets per row, number of rivets per pitch. You can see 1, 2, 3, 4, 5. Accordingly, whatever the case is given, I'll consider what's the number of rivets that I had in the particular pitch. Then I go to whether it's a lap joint or a butt joint with a double cover plate or a single cover plate. Accordingly, I will choose the K1, right? Once I choose it, I will be substituting it into this and I will get a value, 2 p values here. But take care that, but comparing these two values, I will consider a least value of these 2p as for a further design, okay? So now once I do this, next in the same step, I'll go with a transverse pitch. Again the transverse pitch from a data handbook where PT is equal to 2 into D. Then I will choose the same formula over here, substitute and I'll find what is transverse pitch from this equation. So further, with a step 3. For the length of a shank is nothing but a distance after the head of your rivet. Okay. So now again from this you can see from this equation I'm gonna pull it down from a data handbook which says somewhere over here sigma t is a very much concern plus 1.5d to 2t plus 1.7d. So which is of equation 5.9 of page number 63. Yes, sigma t reflects what the total thickness of the either it would be if it is a single plate, the thickness of a main plate, then the plate which you had on the top of a plate, we call it a top core plate or a bottom core plate, the whole thickness is sigma t. Okay. Now followed by the step 4 where you will find out m, margin. I used to say everywhere margin or every time while designing a rivet it is a 1.5 d. From this equation even from a data handbook it gives the same equation, it's a 1.5 d. Now substituting into this again the d would be the whole diameter of a rivet, whole diameter of hole which where you place in a rivet. If you could remember that whole diameter is equal to standard diameter plus 1 mm. So substituting in this I'll find out margin. And the next important is a very important criteria is to find out what is an efficiency. In order to find an efficiency, I do follow some 4 steps over here. First step would be in order to go with the tensile strength, where the equation is somewhere over here, and I find out which is a PT. I do call it as a PT, where it's equal to P minus D into T into sigma T from equation 5.11 of page number 62. Now I mean 63. Now substituting everything into this, I'll get what is PT. Next step would be in order to find efficiency. Again, the next step I do with is a shearing strength, where the equation states to be this, and I would call it as a PS, where the equation comes in here N1, N2. You can see over here N1, N2. N1 reflects single shear, N2 reflects double shear. Where we learnt in our previous video like how to conclude with N1 and N2, if it is a lap joint, butt joint, single pole plate, double pole plate, whether it's a chain arrangement or a zigzag arrangement. Accordingly, I will let you know, or we do come to one conclusion of what would be N1 and N2. Substituting into this, I'll find out what is this shearing strength PS. In the same way, in order to come up with an efficiency, I'll go with one more step, saying as a crushing strength. So again, from an equation, I will draw the PC, where the PC is equal to this equation, which tends to be 5.14 of page number 63, and substituting it into this, I will find out what is PC. And that last step of in order to find efficiency will be the strength of a solid plate. So for this, again, I will be referring a data handbook and drawing up an equation from that, where I call this as a solid P. P is equal to PT into sigma T. Everything will be given to us. Now once I substitute into this, I'll get a value of P. Now very important to find out an efficiency is this equation. Now the efficiency is equal to least of PC, PS and PT. I mean crushing strength, shearing strength and tearing strength. Least of this divided by solid plate strength P into 100. I'll get some value over here, efficiency. Step over here to be taken very importantly. Efficiency should be within the recommended range. Now what is this recommended range? I will come up with this. That recommended range will be there in a table 5.1 of 68, as you could see over here. This is a recommended range of a system. Now in a given, it will be known to us like whether it's a single shear, double shear, and we know the number of rivets per pinch, right? So whatever the value that I get from this equation, efficiency, that should lie between this recommended efficiency values. If it lied, then yes, your design is very much safe. So this is how the design is being taken care while designing the rivet. Thank you.